Welcome to Memo Tutorials. Today we are talking about break-even analysis. Break-even analysis. What is it? It is a tool businesses use to determine at which level of output they will cover their total costs, which is composed of their total fixed costs, TFC, and their total variable costs, TVC, and therefore have a profit of zero. Contribution. It is how much a product contributes to the fixed cost, and then profit after covering its variable cost. Contribution per unit. It is the price per unit minus the variable cost per unit. An example is if one bottle of wine sells for $100 and it costs $80 to make. Therefore, $100 minus $80 equals $20, and this would be the contribution per unit. Total contribution is the total revenue minus the total variable cost. For example, if 100 bottles of wine are sold, then $100 times 100 is 10,000, which would be the total revenue, minus $80 times 100, which would be 8,000, which would be the total variable cost. This would result in $2,000, which would be the total contribution. Another way to find the total contribution is contribution per unit times number of units sold. For example, $20 would be the contribution per unit times 100, which would be the number of units sold. This would result in $2,000. Profit can be determined by total contribution minus total fixed costs. For example, if the rent of the place where wine is made is $1,000 per month, then $2,000, which would be the total contribution in that month, minus $1,000, which would be the total fixed cost in that month, would be equal to $1,000, and this would be the profit. Margin of safety. It is the range of output that surpasses the break-even output. So if that quantity is eliminated, you are at the break-even point. This is an example of a break-even analysis graph. The y-axis here are costs and revenues, and the x-axis here is quantity, also known as output. The four lines here are total revenue, which is the red line, total costs, which is the green line, variable costs, which is the yellow line, and fixed costs, which is the blue line. You can see the fixed costs does not rise and starts above zero. This is because fixed costs remain the same no matter what quantity. Variable costs are rising at the same slope as total costs do, and they begin at zero. This is because variable costs are zero because they depend at zero quantity because they depend on the quantity. And they have the same slope as total costs because total costs equals fixed costs plus variable costs. And since the fixed costs don't change, then the only change in total costs is the same as the change in variable costs. Therefore, these two will always rise at the same rate, and the difference between them will be the same always, which is equal to the value of fixed costs. The total revenue line rises faster than the total cost line, and at the point where it crosses it is called the break-even point, as it is located in Q1. Q1 would be the break-even output, and the y value would be where total costs equals total revenue, as shown in the graph. If the firm were producing at Q2, it would be surpassing the break-even point. The x value of the difference between Q2 and Q1 would be the margin of safety, as shown by the green line on the graph. At the output of Q2, the firm is making a profit, and the profit can be seen at the top of the purple line that denominates Q2. At the top is the difference between the total revenue line and the total cost line. If the firm were producing at Q3, then it would be making a loss, and it would also be shown at the top of its purple line, the difference between total revenue and total costs. However, as it is making the loss, this value would be negative. Now, to calculate the break-even output, there are two main ways, using the contribution per unit or the total revenue equals total cost. With the contribution per unit, the formula is break-even quantity equals fixed cost divided by contribution per unit. An example would be a man selling lemonade and his fixed cost being the lemonade stand and costing $50, and then selling each lemonade glass at a price of $4, and the cost of making each of these lemonade glasses being $2. So you divide 50 by 4 minus 2 and you get 25. This would be the break-even quantity. The total revenue equals total costs method logically uses the formula of total revenue equals total costs. However, it is necessary to convert it to price times quantity equals TFC plus TVC and substitute quantity for X. For example, by using the case of the lemonade stand, the formula we would get is 4x, as the price of each lemonade glass is $4 and x is what we're substituting for quantity, equals 50, which is the TFC, total fixed cost of building the lemonade stand, plus 2x, as 2 is the variable cost for making each lemonade glass and x is thus again the quantity. This would give us x equals 25, which is the break-even output. To determine a profit or loss, we use the formula profit equals total revenue minus total costs, and we then convert it to price times quantity minus total fixed costs plus total variable costs. For example, if the man sells 50 lemonade glasses in a week, then our formula would be 4 times 50, as it's $4 per glass and 50 glasses sold, minus 50, the total fixed cost for building the lemonade stand, plus 2 times 50, which is the variable cost for making each glass, times the 50 glasses sold. This would result in 50, and this would be the profit, $50. Target profit. To calculate target profit, we must use the formula fixed cost plus target profit divided by contribution per unit equals target profit output. So, if you have a defined output or a defined target profit, you can use it to determine its counterpart. For example, if the man selling lemonade wants to make $100 of profit in a week, he needs to know how many glasses he would have to sell. So our formula would be 50, the total fixed cost, plus 100 divided by 2, which would be the target profit divided by the variable cost per unit, and this would give us 75, and this would be the target profit output. If the man selling lemonade knew he could make a maximum of 40 lemonade glasses to sell, then to find his target profit, he would use the formula 50 plus x divided by 2, 50 again being the total fixed cost and x divided by 2 being the target profit divided by the variable cost per unit equals 40, which would be the target profit output. This would give us that x equals 30, so his target profit should be $30. For calculating the target price, the same formula is used, but contribution per unit is replaced with target price minus variable cost per unit. For example, if the man selling lemonade had a target profit of $70 and a target profit output of 40, then the formula would be 50, which is the total fixed cost, plus the target profit of 70 divided by x minus 2, which would be the target price minus the variable cost. And this would equal to 40. This would result in x being 5, and then telling us that the target price for each lemonade glass should be $5. For calculating the break-even revenue, the formula would be break-even revenue equals fixed costs divided by contribution per unit times the price per unit. For example, with selling lemonade, the formula would be 50 divided by 2, which 50 being the fixed cost for the lemonade stand divided by the contribution per unit of $2, times 4, which is the price per unit of each lemonade glass, and the break-even revenue would be $100 according to the formula. The tool of the break-even analysis has both pros and cons. For example, a pro is that it is a simple and visually appealing way of analyzing a firm's finances. Also, it is easy to determine a profit or loss, margin of safety, and break-even at quantity and revenue. Also, the formulas of these concepts yield accurate results. Finally, this break-even analysis can also be used for strategic decisions. However, it also has cons. For example, it assumes that the entire stock of the firm is sold. It also assumes that the revenue and cost lines are linear. Furthermore, it does not represent semi-variable costs. And finally, it is not as useful in dynamic and changing environments. Now for a real-life example.
A real-life example is Spotify, which is an interactive on-demand music streaming platform that has been on the spotlight lately based on their inability to reach break-even point. They offer monthly subscriptions that cost on average $9 and receive additional revenue from their advertisements. Nevertheless, the contribution per unit, which is the sales price minus the variable cost, which in this case is the amount of money that they pay the artist for each time their song gets played, is not able to pay for the fixed costs, which include operating costs and music licensing. In other words, for the current amount of subscribers, which is 50 million, the contribution per unit times the 50 million isn't able to pay for the fixed costs, therefore has not been able to reach the break-even point.